Hi everyone, I hope you are all doing well, and we are officially going to start our unit on proofs. Okay, we're going to focus on what's called two-column proofs, and what I went ahead and did was listed a bunch of different definitions in the if-then form, and then also stated their converse. You will need to know these, either memorize them or just know how to apply them, but you have to be able to recognize them and use these. Okay, so if I have a right angle, we know that a right angle is 90 degrees. So if we put that as an if-then statement, it would be if an angle is 90 degrees, then it is a right angle. And we can also say the reverse. If an angle is a right angle, then its measure is 90 degrees. Okay, we can say the same thing about a straight angle. If an angle is 180, then it is a straight angle. If an angle is a straight angle, then its measure is 180. Okay. Same thing with acute. Okay, so notice all these converses would be true. This is obtuse. Congruent angles. If angles have the same measure, then they are congruent. If angles are congruent, then they have the same measure. Okay. And actually, let's go ahead and add 125 up here and 25 up here so we make sure that we don't assume from a diagram that something is acute and obtuse. So what we did with congruent segments is the same thing for angles. If two segments have the same measure, then they are congruent. If two segments are congruent, then they have the same measure. Midpoint. Midpoint states that if a point divides a segment into two congruent parts, then the point is a midpoint. And the converse is true. If a point is a midpoint, then it divides a segment into two congruent parts. Okay, again, you have to be able to interchange these, be able to use them, know when to apply them, and be able to write them out. If you go back to here, is there a definition that we can use knowing that an angle is 70 degrees? Can we prove that it's acute? Well, we can. If we go to this statement right here, if an angle is between 0 and 90 degrees, then it is acute. So we this page, if angles have the same measure, then they are congruent. And then on the last page, we have if a ray divides an angle into two congruent parts, then we say that the ray is bisected. Let's redraw this. There we go. If a segment bisects a segment, then it divides a segment into two congruent parts. And then both of those are also reversible. Okay. All right, so two-column proofs. So you're always going to start with the given. And basically, what we're going to do is we have to prove what the problem asks us to, okay? When you're doing this, you have to assume that I know nothing when I am reading your proofs, okay? That I literally do not know that a right angle is 90 degrees or that an acute angle is between 0 and 90 degrees. These are the things you have to prove. So we're gonna start off with the given. So measure of angle H equals 70 degrees. And the reason for that is it's given. Okay, so you take this right here and you write given. If there's multiple givens, which we'll do an example of, then you write it multiple times. Okay. Then it says angle H is an acute angle, so that's what I have to prove. So if you go back up to here, I can't go back. I have to all the angles between 0 and 90 that was given to us. And we can prove that it's acute by that definition. So angle H is acute. And we would write out that definition. So if an angle is between 0 and 90 degrees, then it is acute. Did not write a question mark there. I was about to ask you a question. Okay, so the goal then at the end is, did your last reason prove what the problem asked you to? So what I mean by that is my last statement said it was acute. Angle H is acute. So my last reason proved my statement. Now we have to make sure that all the work in between, though, is also correct. Okay? All right, let's look at the second example. So in the second example, we are given two angles, or two givens. So we're going to write both. Angle A is a right angle. And angle B is a right angle. And you don't have to write given multiple times. You can just write given. You can group it all together. Okay, so what we're trying to prove is that angle A is congruent to angle B. So if we were to talk this out, we would say, well, what do we know about right angles? Right angles both have a degree measure of 90 degrees. Okay, well, if they both have a measure of 90 degrees, then they must be congruent. So now we have to write that out in steps. So we would say angle B equals 90 degrees. I could have started with angle A, it doesn't matter. And the reason being, if an angle is 90 degree, is a right angle, then it equals 90 degrees. Okay, but we have to do that for angle A as well. And you can just write same as to. You don't have to write that out again since you were using the same logic twice. Where did I get that from? From that definition page. That definition page is going to be like your lifeline. Now that we have stated both angles equal 90 degrees, now we can say they are congruent. Because if we go back, so if angles have the same measure, then they are congruent. Okay. And at the end, check. Did I prove everything? They are congruent. Those two angles are congruent. Okay. Now, these in-between steps might have seemed a little silly to you, right? Because we know that right angles are 90 degrees, and we know they're always going to be congruent. So we actually have what's known as the right angle congruence theorem, and that is going to eliminate those two steps in the middle that I just did. So instead of having a 4-step proof, we would only have a 2-step proof. Okay, so our theorem is, and this is another one you need to know, if angles are right angles, then they are congruent. You need to know that. Okay. All right, let's go to the next page. So we are given, I don't feel like that's right. There we go. We are given that the measure of angle O equals 90 degrees. Okay, we want to prove that O is congruent to G. Well, from the diagram, we can assume angle G is a right angle. And we would literally just write assume. Why can we assume that? Because there's a little angle box, or a little right angle box at angle G. Okay. Now there's two ways that we can actually approach this proof. We can then show that angle G equals 90 degrees, because if an angle is a right angle, then its measure is 90 degrees, and then prove that the angles are congruent because the measures are the same. But we're going to use the right angle congruence theorem instead. We are going to state that angle O is a right angle. Reason being is because if an angle has a measure of 90 degrees, then it is a right angle. All right, so now we have angle G and angle O are both right angles, so we can use the right angle congruence theorem. We can state that angle O is congruent to angle G because if angles are right angles, then they are congruent. Again, we could have approved this using what we did on the previous page, where we went through and did all their measures, 90 degrees, therefore, since the measures are the same, they are congruent. Or we can use the right angle congruence theorem, which actually will be a lot faster the majority of the time. And again, check, did you prove what you intended to? They are congruent, they are congruent. Just make sure that the work in between follows. Like, think of it as like a maze, okay? You have to follow a certain way through the maze to eventually get to the end. And there's one way to get there, typically. Sometimes you can have roundabouts. Okay, so we have to figure out that way to get there to prove my final statement. All right. Next example. So we're given a lot in this one. We know the measure of angle RST equals 50 degrees. We know that the measure of TSV is 40 degrees. And we know that angle X is a right angle. All of that was given. Okay? So we need to either show that angle X has the same measure as angle RSV, or show that angle RSV is a right angle. Okay, and that's the route we're going to take. So what we first need to do is state that measure of angle RSV equals 90 degrees. That is by the angle addition postulate. You actually learned that in chapter 1. Okay. And if an angle is 90 degrees, we know it's a right angle. So angle RSV is a right angle. And again, it would be because if an angle is 90 degrees, then it is a right angle. Okay, so now we have angle RSV and angle X are both right angles. And by using the angle congruence theorem, we can state that they are congruent. So if angles are right angles, then they are congruent. Okay, so we have one last example, and this is going to be our longest proof. So look at the final statement. It says NG bisects angle ANE. In order to know that something is bisected, you need to make sure that you know that the two parts are congruent. So there's actually, again, two ways we could approach this problem. We could go along the avenue of finding the actual angle measures, or proving that the two angles are right angles, therefore they are congruent. Okay? So let's go ahead and do that. So start off by listing the given. Okay. And if you label anything on the diagram, it has to come from the given. You cannot assume. So we know that angle ANG is a right angle. GNL is 35 degrees, and this is 55 degrees. Okay, we can't just say, oh, the angle measures are the same, they're congruent. No, we don't know that. Okay, we have to actually prove that. So I'm first going to show that angle GNE equals 90 degrees. We can state that because the angle addition postulate. Okay. If angle GNE is 90 degrees, we also know that angle GNE is a right angle. And again, if an angle is 90 degrees, then it is a right angle. So now we know that angle GNE and angle ANG are right angles. And what do we know about right angles? They're congruent. So angle GNE is congruent to angle ANG because of the right angle congruence theorem. That if angles are right angles, then they are congruent. Okay. Now that we show that the angles are congruent, they have the same measure, we can now say that ray NG bisects angle ANE. Okay. And that would be one of the last ones that was listed. So if a ray divides an angle two congruent parts, then the ray bisects the angle. Okay, so I know this is new to a lot of you, and we're going to be doing lots and lots and lots of practice. We're going to go through this chapter fairly like one day at a time. There's one day we have to double up on 2 lessons. But other than that, we're going to just keep practicing, okay? Remember, you cannot assume anything, and you can't just go from point A to point C without explaining point B. You have to assume I know nothing when I am reading your proofs. Okay? All right, I hope you enjoyed our first day of 2-column proofs.